Hi guys, in a previous video we solved a linear differential equation. So now let's look at another example. So solve the differential equation dy over dx is equals to e to the power of y times 1 plus y, all divided by e to the power of 1 over 2 times y squared plus x times e to the power of y times y squared minus 1. So the first thing we need to do, we need to get our differential equation in the form dy over dx plus p of x times y equals q of x. So to do this, we can expand this bracket. Dy over dx is equals to e of y, because e to the power of y times 1 is e to the power of y, all divided by e to the power of 1 over 2 y squared plus x times e to the power of y times y squared minus 1 plus y e to the power of y times y is equals to y times e to the power of y, all divided by e to the power of 1 over 2 y squared plus x e to the power of y squared minus 1. Y squared minus 1. Okay. So I want you to recall, previously I told you that some differential equations are very difficult to solve, or sometimes they have no solution. So if you come across a differential equation that's, you can't find a solution because we're unable to get this differential equation in this form, what you can do is you can actually try reciprocating dy over dx and making x the dependent variable instead of y, and making y the independent variable. So what I'm trying to say is we change this, so dx over dy and then is equals to e to the power of 1 over 2 y squared plus x times e to the power of y squared minus 1, all divided by e to the power of y times 1 plus y. Now, so dx over dy. And now, to solve the differential equation, we need to put this in a linear differential equation. So it's dx over dy plus py times x is equals to q of y. Okay. So what I've done is I've reciprocated the equation, making the dependent variable to become y, to become x, and y to become the independent variable. So now we just need to see if we can make this equation into this, if we can rewrite this equation into this equation. So we can, again, expand the fraction dx over dy is equals to e to the power of 1 over 2 y squared divided by e to the power of y times 1 plus y plus x times e to the power of y times y squared minus 1 divided by e to the power of y 1 plus y. Okay. So now we can see that, we can actually get this equation in this format because dx divided by dy and our p of y is going to be x times e to the power of y, open bracket, y squared minus 1 divided by e to the power of y times 1 plus y. And our q of y is going to be e to the power of 1 over 2 y squared divided by e to the power of y plus e to the power of y times 1 plus y. So now, to get this into this format, I'm going to bring this onto the left-hand side, and now it becomes d of x divided by dy minus x times e to the power of y times y squared minus 1 divided by e to the power of y 1 plus y is equals to e to the power of 1 over 2 y squared divided by e to the power of y 1 plus y. Right. So we see, so yes, I hope you can see that, you know, we can now get this equation into this format, and now we can solve our linear differential equation. So now we can actually simplify this a bit further. So we can do x times e to the power of y squared minus 1 is equal to, remember, y squared minus 1 is equal to y squared minus 1 y squared plus 1. That gives us, my apologies. Yeah, sorry about that. That gives us y, so we can actually open a bracket of y squared minus 1 to give us y minus 1 times y plus 1, and that gives us y squared minus y squared plus y minus y minus 1. So we can do dx over dy minus x e to the power of y minus 1 times y plus 1, all divided by e to the power of y 1 plus y is equal to e to the power of 1 over 2 times y squared divided by e to the power of y 1 plus y. So now, so we can cross this out. So we can, simplify it further. E to the power of y divides e to the power of, well, yeah, you can see that, yeah, so it divides e to the power of y times y plus 1. But I don't know, if I put it here so you can actually see it properly what I'm trying to do. Y minus 1. So this crosses out, so it's equals to dx over dy minus x times, because e to the power of y, open bracket, y plus 1 divided by e to the power of y plus 1 crosses out to get 1. So it's going to be minus x times y minus 1 is equals to e to the power of 1 over 2 y squared divided by e to the power of y 1 plus y. So now our equation is in this form, is in this form. So now we can find our p of y. This is equals to, our p of y is equals to minus y minus 1. Can open a bracket. This is equals to 1 minus y, p of y, and our q of y is equals to e to the power of 1 over 2 times e to the power of 1 over 2 times y squared divided by e to the power of y 1 plus y. Right. So now we can apply integrating factor. So using our formula, the integrating factor is e to the power of p of y dy, and our p of y is e to the power of 1 minus y dy. So our integrating factor becomes, so to integrate 1 minus y, we get so e y minus y squared divided by 2. So we can actually, using the exponential rules, we know that so e to the power of a plus b is equals to e to the power of a times e to the power of b. So using that rule, we're going to expand it. So e to the power of y times e to the power of minus 1 over 2 divided by 2. I mean, it is true as well that e to the power of a minus b is equals to e to the power of a divided by b, but we can use this as well, and it's going to be correct. So now we multiply equation with our integrating factor, and our general solution now becomes x times our integrating factor e to the power of p of y dy is equals to the integral of q of y times our integrating factor e to the power of the integral of p of y dy plus c. So we substitute e to the power, we substitute this into our formula. That's going to be x times e to the power of y times x times e to the power of y times e minus y squared divided by 2. This is equals to the integral of our q of y is e to the power of 1 over 2 y squared divided by e to the power of y times 1 plus y times our integrating factor times e to the power of y times e to the power of minus y squared over 2 plus c. Right, so we simplify our equation. This gives us x times e to the power of y minus y squared divided by 2 is equals to, before we actually integrate this, we can simplify this further. I'm just going to write this down here. Okay, so we can simplify this further. So e to the power of 1 over 2 y squared times e to the power of minus 1 over 2 y squared is equals to 1, because, one is, what this is saying is e to the power of a times e to the power of minus a. So this equals to 1. Right, so we can cross that out and cross that out. And also, e to the power of y divided by e to the power of y times 1 plus y. We can cross this out as well. And that simplifies our integral to 1 integral of 1 over 1 plus y plus c. So to find the integral of that, it becomes ln, the absolute value of 1 plus y plus c. So x times e to the power of y minus y squared divided by 2. And this is our general solution. To get this in explicit form, to get y on its own, we divide both sides by, we divide everything by e to the power of y minus y squared divided by 2. That gives us x is equals to ln absolute value of 1, ln x of 1 plus y plus c, all divided by e to the power of y minus y squared divided by 2. Right, note that okay, so e to the power, so 1 over e is equals to e to the power minus 1. So we can use this rule in here to simplify this further, is equals to, so this becomes minus y, e to the power of minus 1 is become plus y. So e to the power of y squared divided by 2 minus y times, all times, ln absolute value of 1 plus y plus c. And that's our final solution. So we've solved our differential equation. Dy over dx. We see that we couldn't find a solution. So what we done was we inversed the differential equation, making d of x, making x the dependent variable, making y the independent variable, and solving the differential equation in this form. So dx divided by dy plus p of y times x is equals to q of y. So this becomes our independent variable. Y becomes our independent variable and x becomes our dependent variable. So this is a really cool tip for you. If you're unable to find a solution to the differential equation, try to reciprocate it and see if you can actually solve the differential equation. If you can put the differential equation in the linear differential equation form. If not, there are other methods you can use to try to solve the differential equations, and I'm going to talk about that in the next video. Thank you.